We rarely think of the sky as a physical object, but you are sitting at the very bottom of a massive ocean of invisible gas. This ocean is a specific mixture, 78% nitrogen and 21% oxygen, and it stays pinned to the surface because gravity prevents it from venting into the vacuum of space. This massive column of gas exerts a crushing weight on us at all times. We only survive it because our bodies push back with an equal internal pressure, neutralizing the force from the outside. Far from being empty space, this blanket is a violent shield. It constantly burns up incoming meteorites and filters out lethal doses of cosmic radiation. To see why the wind blows, why it rains, or how massive storms shape civilization, we have to look past the empty sky and learn the mechanics of this invisible ocean. This chart shows the atmosphere's vertical structure, divided into distinct functional layers defined by predictable changes in temperature and density. At the outer extremes, the thin exosphere fades into the vacuum. Just below lies the thermosphere, where temperature spikes as gas molecules absorb extreme solar X-rays. This is where we see the aurora, caused by solar wind interacting with atmospheric gases, causing them to glow in vivid colors near the magnetic poles. Below that, the mesosphere acts as a graveyard for meteors, while the stratosphere just beneath it houses the ozone layer, which filters out the sun's most harmful radiation. We live in the troposphere, the lowest 12 kilometers. This is the densest layer of all, containing nearly all the planet's water vapor and serving as the engine room for the world's weather. While the upper layers serve as a cosmic shield, the dense troposphere is where the actual thermodynamic machine of weather runs. This engine is fueled by incoming solar energy. Because Earth is curved, energy hits the equator directly, but glances off the poles. This creates a chain reaction. Hot air rises, leaving a low-pressure void, while cold air sinks. Wind is air rushing to find balance. You can see this rule in action on a microscale at the coast. At night, the land cools down much faster than the ocean water. The resulting cold, heavy air over the land naturally rushes out toward the warmer, low-pressure sea to equalize the system, creating a steady land breeze. This simple mechanical equalization of hot and cold is the gear driving every passing breeze and local storm on the planet. This exact coastal mechanic scales up to drive one of the most powerful weather systems on Earth, the Indian monsoon. This map shows the summer monsoon setup. As the sun bakes the Indian landmass, air heats rapidly and rises, creating a continent-sized low-pressure vacuum. Moist, high-pressure air from the cooler Indian Ocean forcefully rushes inland to fill the void, sweeping across the country and dragging millions of tons of water. The monsoon is the mechanical result of this continent-sized pressure vacuum violently pulling the ocean's moisture inland to restore balance to the system. Because this thermodynamic engine follows the rigid laws of physics, its massive seasonal shifts are incredibly reliable and predictable. Ancient civilizations used these patterns to survive. By tracking lunar mansions or nakshatras, they could predict the exact onset of the rains and time their crops to the atmosphere's reliable rhythms. Today, the agricultural success and economic stability for over 1 billion people still depend on this pressure equalization engine firing on schedule every year. The atmosphere is Earth's great distributor, an elegant machine that uses every gust of wind to move heat and water across the planet.